Hello students, and today we're going to be taking a look at functions. This is kind of a prelude to what we need to look at our trigonometric functions, which is going to be our main unit. So a function is a rule for mapping one group of numbers to another. So let me give you some examples of functions that we've seen in the past. So for instance, if I give you something like y is equal to 3x plus 1. This is considered a function. This part here, the 3x plus 1, is the rule, and our x value is considered our input. Our y value is considered our output. And normally what we do is, for a function, we write them in an ordered pair, input, comma, output. So let's take an example here. If I'm using this function, y is equal to 3x plus 1, and I use the input -3, what output will I get? So pause the video and try substituting in -3 into x here. So let's see what value we're going to get for our output if I let x be equal to -3. Well, I'm going to get 3 times -3 plus 1. This is equal to -9 plus 1, and that's equal to -8. So what this says then is that if my input value is -3, this gets mapped to the value -8. So why is this important here? Well, when we take a look at our sine, cos, and tangent functions, these ones have an input-output relationship as well. So what I'd like you to do is I want you to find your sine, cos, and tan button on your calculators. Okay? So sine, cos, and tan are functions. And for each one of these, they have a specific input. So the first thing that we want to do that's very important is you want to make sure that your calculator is in degree mode. So at the top, it should say degree, should say deg, D-E-G, or D-R-G. There should also be a mode button on your calculator to change that. So let's take a look at taking some specific input values here and checking to see if our calculators are calibrated. So let's take a look here. What we're going to do is we're going to have our degrees here. So our input here are all degrees. So the sine of 30 degrees, the cosine of 60 degrees, the tan of 45 degrees, and we want to see what our specific output is going to be here. Okay, so I want you to punch these into your calculator. So pause the video here and punch these on in. So what we'll find is the sine of 30 gives us an output of 0.5. The cos of 60 gives us an output of 0.5. And a tan of 45 gives us 1. So the idea here is that the rule is our sine function. And it used to be that we had these big, long tables that we'd have to look up, okay, what's the sine of 30? You look through this huge, long table to try to find where it is. Now, thankfully, we have a calculator that takes care of all the lookup for us. So what this does is this maps a degree between that's greater than 0, less than 90, to some number. Okay? For sine and cos, it's a number that's between +1 and -1 inclusive. And for tangent, it's any real number. Okay? So what we're going to be taking a look at is, in our following videos, well, what is sine, what is cos, and what is tan? But for now, what we want to do is just get familiar with the idea that these are functions that require an input and give us a specific output. Hello students, and welcome to Trigonometry 1.2. This is vocabulary and relative naming. So grab a pencil and piece of paper and please follow along. So we're going to be taking a look at some of the important vocabulary points that's reviewed from grade 8 and 9 here. So you recall that the hypotenuse is the longest side of a right triangle. And a right triangle is defined as any triangle with the largest angle being 90 degrees. So if the largest angle is 90 degrees, then the two other angles have to be less than 90, because all angles in a triangle must add to 180. So in this case, we call them acute angles. An acute angle is defined as any angle that's greater than 0, but strictly less than 90. Okay, so these are acute angles. So please familiarize yourself with this vocabulary, because we're going to be using this pretty regularly here. So one of the first skills that we need to have is to always be able to identify what the hypotenuse is in any given right triangle. So in this case here, we can kind of do a visual inspection to tell what the longest side is, but thankfully there's another way we can do it as well. The hypotenuse is always directly across or directly opposite the 90-degree angle. So for instance here, this is our hypotenuse. So you don't always have to write out hypotenuse. You can write out hip, as in hipster, or you can write out just H. So it's up to you, your choice. Just use whichever is the most appropriate. So what I'd like you to do is to copy down the 3 remaining right-angled triangles and to identify which side is the hypotenuse. So please pause the video. Okay, so let's take a look. So for this one, we draw an arrow directly across. We find that here is the hypotenuse. Draw an arrow directly across. Here's our hypotenuse. And draw an arrow directly across. Here's the hypotenuse. So you don't have to draw the arrow. It's simply a way to help you remember. So if you can visually draw the arrow in your mind and then identify the hypotenuse, as long as you're identifying the hypotenuse correctly 100% of the time, that's what matters. So now that we've got the hypotenuse figured out, well, what do we call these two other shorter sides? Well, as far as grade 8 and grade 9 goes, we simply called them legs. So here's a leg, and here's a leg, and here's the hypotenuse. Now in grade 10, we're going to add another level of detail, and we're going to give specific names to the legs depending on which acute angle we're using as a reference. So here I've got a right angle triangle X, Y, Z. So recall that we name triangles by the vertexes. So here the vertex X, Y, Z. Generally we do it in alphabetical order here. So I'm going to be using angle X here, or corner X here representing that angle, as my reference. So notice that your hypotenuse remains fixed. The hypotenuse is always the hypotenuse. It's the names of the legs that we're going to be really interested in here. So the two different names we can have are the opposite leg and the adjacent leg with respect to this angle that we're looking at. So let's start with opposite leg. So the side which is opposite or across from this angle is this side right here. So here's your opposite, or OPP, So if you take a look here, we've got our opposite. Now, which ones left are adjacent? But there's another way to figure out the adjacent. Notice that any angle is made up of 2 lines. In the case of an acute angle, in a right angle triangle, one of the lines is always the hypotenuse. The other leg is always your adjacent side. So what we're going to be doing next is practicing, given different reference angles, can you identify which side is hypotenuse, which side is opposite, and which side is adjacent. Students, and welcome to 1.2 relative naming. We're going to get some practice here. So notice that I've got 2 identical right angle triangles, both named L, M, N, hard to say fast. So in this triangle, I'm going to be referencing angle L. In this triangle, I'm going to be referencing angle N. We want to get practice naming all 3 sides of these right angle triangles using our proper naming techniques. So recall that the hypotenuse is always directly across from the right angle. So here's our hypotenuse. And notice that it's going to stay fixed. Your hypotenuse is always the hypotenuse. That never changes. What is going to change are the names for our opposite and adjacent sides. So based on the last thing we looked at, I want you to pause the video, and relative to L and relative to N, I want you to name the two remaining legs in each set. Okay, so let's take a look here. So relative to L, well, L is made up of these two lines. One of them is the hypotenuse. The other is the adjacent side. So if I go directly across from angle L, I get the opposite side. So we have adjacent and opposite. In this case here, I'm referencing angle N. Angle N is made up of the hypotenuse and this line. So this is the leg. It must be the adjacent leg. And in this case here, the leg which is directly across from angle N is our opposite leg. So notice here that the hypotenuse stays the same, but the opposite and adjacent swap when we swap our acute angles of reference here. So here when I'm referencing L, adjacent, opposite. Here when I'm referencing N, opposite, adjacent. So we're going to get some practice with this now. So what I'd like you to do is to copy down the 4 right angle triangles with the names that you see here. What we're going to be doing is we're going to be naming each of these triangles, all of their sides with respect to the indicated angle. So here we're naming with respect to X, here with respect to P, here with respect to S, and here with respect to L. So pause the video and we'll take a look at the solution. So let's start by identifying the hypotenuse in every single triangle. So the hypotenuse, our first one is here, second one here, third one is here, and fourth one is here. Now notice that I'm not drawing in the lines. Now if you want, you always can, but it's not necessary. So now let's find out the adjacent. The adjacent, remember, is made up, you can find the adjacent by looking at what lines make up the angle, and then it's simply the leg that makes up the angle. So here is your adjacent. Similarly, here is your adjacent. Here is your adjacent. And here is your adjacent. So now what's left is the opposite, opposite, and opposite. So we're going to get a worksheet practice now, and I want you to go through that and to carefully master this skill, because this is incredibly important for what we're going to be doing for the rest of the year. We want to make sure that 100 times out of 100, you can always correctly label the sides of a right angle triangle with respect to a given angle. Students, and welcome to 1.3. We're going to be taking a look at the sine function, the cosine function, and the tangent function. So let's start off with the sine function here. So the sine function is defined as the sine of an angle in a right angle triangle is exactly equal to the opposite length divided by the hypotenuse length. So the idea is sine, cos, and tan only apply to right angle triangles. That's how they're defined. So please keep that in mind. We cannot apply the sine, cos, and tangent functions to non-right triangles. So we've got the triangle here, 5, 12, 13, named JKL. So let's take a look here. First of all, because this is a right angle triangle, the sides must all obey Pythagoras' theorem. So notice that 5 squared plus 12 squared equals 13 squared. So all of our examples are going to follow Pythagoras' theorem. So what we've got here as our very first step in every single one of these problems, we need to identify, well, what are the hypotenuse, opposite, and adjacent sides for this triangle and our angle here. So here our reference angle is angle K. So let's start off. So our hypotenuse is this side. Our adjacent side is here, and our opposite side is here. So the idea is that we're going to have this fraction, the opposite length, divided by the hypotenuse length. So, well, our opposite is 5. Our hypotenuse is 13. So this is the fraction 5 over 13. So the sine of K is equal to exactly 5 over 13. So I want you to pause the video here, and I want you to try out, well, what's the sine of J? Okay, so let's take a look. So what we want to do first is we're simply going to identify all three sides. So again, notice that your hypotenuse stays fixed. It never changes. So in this case, here is your adjacent, and here's your opposite. So we're going to be looking for opposite over hypotenuse. So here our opposite length is 12, and our hypotenuse length is 13. So we get the fraction 12 over 13. So here, what we've got is we've got the sine of an x, sine of some angle x. So this is another way that the problems can be defined. Instead of giving the full name for the triangle, sometimes they just tell us we have some unknown angle, and we'll include the little angle sign here. So recall from our last one that sine is just the opposite side divided by the hypotenuse, and sometimes you'll see just using O and H to abbreviate opposite and hypotenuse. So what we're going to do here is we're going to find out, well, what is the sine of angle x here, and what is the sine of angle x in this case. So I'd like you to pause the video and try this one out. So let's see what we get. In this case, what we want to do is we want to name all of our sides with respect to x. So I've got my hypotenuse, which is going to stay fixed. Here is my opposite side, and here is my adjacent side. So I'm looking for the opposite length divided by the hypotenuse. So here's my opposite, and here's my hypotenuse. So I get the fraction 3 over 5. Oops, sorry. 3 over 5. So let's do the same thing in this case. Notice that we always start out these examples, and we're going to do all of our questions the same by identifying and naming all three sides with respect to our given angle. So in this case, let's start with our hypotenuse. We've got our opposite, and we've got our adjacent. So we're going to be looking for the opposite length divided by the hypotenuse. So that's 4 and 5. So we get the fraction 4 over 5. Students, and welcome to the cosine function. So cosine is defined as one of the acute angles. The cosine of it is equal to the adjacent length divided by the hypotenuse. So you may be seeing a little bit of a pattern here. So let's take a look at our steps to solving this. So here I've got a right angle triangle, 12, 28.8, 31.2, and notice that again, all of our sides have to follow Pythagoras' theorem. So 12 squared plus 28.8 squared is exactly equal to 31.2 squared, and this is always going to be the case. So we want to find out, well, what is the cosine of angle x in this case, and what is the cosine of angle y in this case. So let's get started. Our very first step, as in all of these, is going to be to find out what is the relative naming. So we've got our hypotenuse side, we've got our opposite side, and we've got our adjacent side. So cosine of an angle is defined as the adjacent length divided by the hypotenuse. So we've got our adjacent side here, and we've got our hypotenuse here. So we're going to get 12 over 31.2. So I'd like you to pause the video and to try this out for the cosine of y. So let's see what we get here. So we're going to start with our naming. So here's our hypotenuse. Here's our opposite side. And here's our adjacent. So what we're going to get here is something that's different than before because our reference angle has changed. So if you change the reference angle, you get a completely different answer. So let's see here. In this case, our adjacent side, 28.8, and our hypotenuse, 31.2. So we get 28.8 over 31.2. Now these aren't our final answers because notice these aren't proper fractions. We always want to have fractions that are proper fractions in lowest terms. So let's take a look at how to do this. So we've got 12 over 31.2 and 28.8 over 31.2. And let's take a look at reducing these to lowest terms. So remember that any fraction is just the division statement. So this is the same as 12 divided by 31.2. So if you type this into your calculator and then press your equal sign, okay, then directly after that, press your A, B, C button. So this allows you to use the power of your calculator to change this into its fractional form. And this will give you 5 over 13. So I want you to pause now, and I want you to try it for 28.8 over 31.2. So let's see what we get. We have 28.8 divided by 31.2. We press our equals key, we press our ABC key, and we get 12 over 13. So this is a skill that you've got to master. So remember, use your calculator efficiently. Don't let it use you. And welcome to continuing 1.3. This is the tangent function. So the tangent function is defined as one of the acute angles of a right angled triangle. The tangent of it is equal to the opposite side divided by the adjacent side. So let's take a look at an example, and then I'll have you try solving this one over here on your own. So let's take a look. So we're going to have, got my pen here, sorry. So first step is we need to find out and name all of the sides. So let's get to that. So we've got hypotenuse, we've got opposite, and we've got adjacent. So notice that the tangent function is only interested in the adjacent side with respect to x and the opposite side with respect to x. It's taking opposite divided by adjacent. So we're going to have 6 over 4.5. So let's take a look here. This is going to give us 6 over 4.5. Oops, sorry. There we go. And now what I'd like you to do is I want you to try out this one on your own. So copy it down and pause the video, and we'll take a look at the solution. So for this one, once again, our first step is going to be to find out, well, what are all of the relative sides? So we've got adjacent, and we've got opposite here. So we're looking for the opposite length divided by the adjacent length. And for this one, we're going to get 4.5 over 6. So just as before, these aren't our final answers because what we need to do is to change these into improper fractions, or proper fractions. In this case, they will be improper, in lowest terms. So let's take a look at how to do that. So this first one's just a little bit different because you notice that 6 is larger than 4.5. So this is going to be an improper fraction, meaning that the numerator is going to be larger than the denominator when we're finished. So again, we're going to use the same process as before. We're going to have 6 divided by 4.5. We're going to hit our equals key. And in this case, we're going to do something a little bit different. Because we know that this is going to be an improper fraction, we're going to press our second function button, also your shift button, and then we're going to press the ABC button. Okay? And we're going to find out that this is equal to exactly 4 over 3. So what I want you to do is to try the process. This one is going to be a proper fraction, so you can leave out this second function business here. So pause the video and give it a shot. So what we're going to have here is this is going to be 4.5 divided by 6. You press the equals button. We're going to press our ABC button, and this is going to be equal to 3 over 4. Now the interesting thing about the tangent function is that if you're taking the tangent of two different acute angles in the same triangle, notice that they're always going to be reciprocals of one another. So that's a quick way to check your answer. So notice here that because the opposite and adjacent switch when you change which acute angle you're looking at, the tangent of one acute angle in the same triangle will always be reciprocal of the other acute angle in the same triangle. So it's just a neat little thing to see. Hello students, and welcome to the final part of your lesson for today. This is a review of sine, cosine, and tangent. So I'm going to start off giving you a mnemonic. A mnemonic is a way to remember important information. So we've got SOHCAHTOA. It's a good way to remember how the sine, cosine, and tangent functions are defined. So, S-O-H, this is sine is equal to opposite over hypotenuse. C-A-H, cosine is equal to adjacent over hypotenuse. And TOA, tangent, is equal to opposite over adjacent. SOHCAHTOA. Now, remember that the sine, cosine, and tangent functions are given to you on your data sheet, but as you progress later in your academic careers, SOHCAHTOA is going to stay with you because trigonometry is an incredibly important part of mathematics. So let's take a look at what we've got here today. Notice that down below here I have the shortened forms. So sine, we drop the E, and sine of x as it appears in your calculator. Cosine, we drop the I, N, and E, so for just cos, but still cosine. And tangent, we drop the G, E, and T, and on your calculator it's just tan. Okay, so sine, cosine, and tangent. So you may have seen this as sin, cos, and tan, but they are the exact same as sine, cosine, and tangent, just used to take up less space on the calculator. So in this point here, what we want to do is we want to bring our skills together. So I've got a reference angle here of x, and what I want to do is I want to find out, well, what's the sine of x, what's the cosine of x, and what's the tangent of x. So let's take a look here. Remembering that our very first step in each one of these cases is to identify all the sides. So I've got my hypotenuse, I've got my opposite, and I've got my adjacent. So remember, if you're not yet comfortable at naming the sides, please come in and get some extra help. I've got some extra worksheets that you can do, but naming of the sides is a fundamental part of this unit. So please make sure that you've mastered that. So let's take a look here. So sine is defined as opposite divided by hypotenuse. So if we take a look here, my opposite side is 18, and my hypotenuse is 19.5. So what is cos defined as? Cos is defined as adjacent over hypotenuse. So my answer here is going to be 7.5 over 19.5. And my tangent is identified as the opposite divided by the adjacent, and this is going to be 18 over 7.5. So notice that we're not quite done yet. What we need to do is to reduce these into their lowest. So what I want you to do is to pause the video here and use those calculator skills to reduce these into their lowest terms. So let's see what we get. 18 over 19.5, this is going to be a proper fraction. So doing this one using the proper fraction method, we get 12 over 13. This is also going to be a proper fraction, so using the proper fraction method, we get 5 over 13. This is going to be an improper fraction, so using the improper fraction method, we're going to get 12 over 5. So, oops, sorry. So put that in there. It really doesn't want to do that. There we go. So what we get is the sine of x is 12 over 13. The cosine of x is 5 over 13. And the tan of x is 12 over 5. So notice that we're just applying these main ratios to our specific angle and our relative naming. So what we're going to try next is a practice question for you to do on your own, and then we'll check the work here together. So I'll give you some practice here to try these out on your own. So we've got our angle here, x. We've got a right angle triangle with sides 9, 21.6, and 23.4. I want you to find what is the sine of x, the cosine of x, and the tangent of x in simplified form. So pause the video and give that a try. So let's take a look at what we're going to get here. So the very first step, as always, is to identify our three sides. So hypotenuse, opposite, and adjacent. So we can also put in, well, what is our mnemonic to help us remember? So remember that we're going to be using this so, ka, toa. And this is really helpful. Now remember, it's going to be on your data sheets. You're always going to have it. But so, ka, toa is something that I strongly recommend that you practice, just because it's a handy way to get it ingrained in your memory. So sine takes a look at opposite and hypotenuse. So our opposite is 21.6, and our hypotenuse is 23.4. So over 23.4. So now let's take a look at what cos is going to give us. So cos is adjacent over hypotenuse, so that's 9 over 23.4, and our tangent is 21.6 over 9. So at this point, what we want to do is we want to put these into our calculator and to change them into our simplified form. Okay, so remember that what we're going to do is we simply use our ABC function button to help us out. So in this case, this is going to be 12 over 13. This is 5 over 13. And here is our improper fraction. And this is going to be 12 over 5. So I hope that went well. And remember to take notes on these videos. And what we're going to be doing is the practice homework in class. Have yourselves a great evening.